Today we are looking at how to determine whether a game is fair or unfair using probability. Please copy down the standard benchmark indicator on a clean page in your notebook. The student will determine and interpret the probability of an event, determining whether a game is fair or unfair. Fairness and unfairness. A game is fair if each player has the same probability of winning. The game is unfair if one player has a greater probability of winning. You can determine if a game is fair or unfair by comparing the probabilities for winning. Example: in a game, two counters are tossed. One side of each counter is black and the other side is white. Player A wins if the colors are the same, and player B wins if the colors are different. Is the game fair? There are two outcomes for each cube, or counter. Since there are two counters, there are 2 times 2, or 4, possible outcomes. Player A wins if both counters are black or if both are white. The probability of player A winning is 2/4 or 1/2, or 50%, so the game is fair, because it means player B wins the other 50% of the time. Try it. There are 4 green buttons and 8 blue buttons in a bag. Player A wins if a green button is pulled out. Player B wins if a blue button is pulled out. A, how many possible outcomes are there? There are 12 because there are 12 buttons. B, how many ways can player A win? We know player A wins if a green button is pulled, so there are 4 ways for player A to win. C, in how many ways can player B win? Well, we know there's 8 blue buttons in the bag, and player B wins if a blue button is pulled out, so there are 8 ways for player B to win. D, what is the probability of player A winning? It's 4 out of 12, which simplifies to 1/3. E, what is the probability of player B winning? That's 8 out of 12, so 8/12, which simplifies to 2/3. F, is the game fair or unfair? Explain. It's unfair because the players do not have an equal chance of winning. Decide if each is a fair or unfair game. Explain. G, a 12-sided number cube is rolled. Player C wins if the number rolled is even. Player D wins if the number rolled is odd. Well, we know the numbers go from 1 to 12, and there are 6 odd numbers in there and 6 even numbers. So each player has an equal chance of winning, so the game is fair. For H, we have 3 coins are tossed. Player E wins if 1 head and 2 tails are tossed. Player F wins if 3 tails are tossed. So the first thing we need to do is write out all the possible outcomes for this. And an easy way to do that is to do a tree diagram. So I'm going to click to the next page here, and we're going to create a tree diagram together. So we're going to start with tossing the first coins. We could get heads or tails. From that, a second coin is tossed, and again, we could get heads or tails for either option. Next, we're going to toss a third coin. So again, we're going to stretch out the tree diagram and create heads and tails coming off of each of the options. So now we have our tree diagram of tossing our 3 coins. We can see there are 8 possible outcomes from this tree diagram. So now we need to figure out what the possibility of each player winning is. So player F wins if 3 tails are tossed, and there's only one option out of the 8. So player F has a 1/8 chance of winning. Next, we need to look at player E. Player E wins if 1 head and 2 tails are tossed. So we're going to go through and look for each one of the options where that happens. So as we can see there, player E has a 3/8 chance of winning. So this game is not fair because the chances of winning are not equal. Please make sure you have all of the work copied down, including the tree diagram, and glue this page in your math notebook.